Today we are going to solve the two-sum problem using the optimized approach. I have already told you the brute force approach yesterday. Okay, so a question is also yes of yesterday that we have given an array. Sorry, we have given a nums array which is equals to 2, 7, 11, and 15, and the target that is equals to 9. Here it is equals to okay. Uh, so yeah. An brute force approach contains the big O of n square time complexity, which is a not a optimized approach. So we will use a hash map. The main idea behind it very simple. Instead of asking which two numbers add up to target, we will ask what number do I need to reach the target. You understand? Okay, let me take an example. Here, our first number is 2. Our first number is given as first number equals to 2. To reach the target 9, we need what? 9 minus 2, that is equals to 7. So we have to check whether there exists a 7 value in the hash map or not. If that is not exist, then we will move ahead. Otherwise, we will return the index and the value of that hash map. Okay. So we store 2 along with its index, because when we go to the 2, then 2 2 is not present there, right? We will check if the 7 is present already in the hash map or not. But we will see our hash map initially empty. So 7 is not present there. So we store 2 along with its index. Here index is 0. Here this value is stored in the hash map. This is the element and this is the index value. Okay. So step 2, when we move to step 2, now we move to 7. Now we'll move to 7. Again calculate the required number. 9 target minus that element, which is equals to 2. Now again we will check the hash map if the 2 is already in the hash map or not. Yes, 2 is already there, right? Because we have stored here. Here we have stored 2 and 0 in the hash map. So 2 is already there. So we will, that means we have a pair. We have found a pair that the answer that will be equals to indexes. The answer indices, what is that? 0 and 1. Why? Because here this value is already present. This value is already present in the algebra. We have found this value for 7. We are here at 7, right? So this value 7 value is at which position? 1, and 2 values at which position? 0. So we have returned our pair like 0 and 1. You understand? If you have any doubt, then you can ask me again. I'll tell you that. Why does this work? Because instead of searching the entire array in the brute force approach, we are going again and again to search for that element, right? We are again traversing that array, but here we are only checking that array once. Okay, the hash map, whether the required number already exists in constant time, that is big O of 1. Since we visit every element only once, the overall time complexity becomes big O of n, right? So I'll tell you now the code. The code we will take unordered hash map, unordered map, that will be also called as hash map. Unordered map, that is int, comma, int, right? Map or MP. We can take it as like this. One second, we erase that. Here, MP. Okay. This hash map stores the number as the key and its index as the value. Now we will search for that number. We will go again and traversing that array. In I equals to 0, I less than nums dot size, we will go till the size of that array, right? And I plus plus. Okay, we traverse the array only once. That's why we have only run one loop here. Now we have to calculate the like we target minus that element. That is the number we have required, right? So we take it as a second number or any variable. We can take it as b. Okay, you can take it as already any kind of, that is will be equal to target minus nums of that, nums of that number. Okay, this calculate the number we need to reach the target. Now we will find if our map, if in the map we find that b, if we find that not equals to mp dot end, if the required number is already in the hash map, we have found the answer, because here we have go till n, but the number we have found that is not equals to mp dot n, means the element not equals to not reach the end of the array. we have found the array behind it. We have found that element behind. So we have found that number, right? So yeah, we will return what? Return MP and B, comma I. We will return this pair, right? Because we have to return that complement value, and that complement value is what? Target minus nums of I. That value we have reached, and the index value, right? Return the index of the previously stored number and the current index. And then if that is if not runs, then we will do what? MP nums of I, that is equals to I. Why we have done this? Because if the required number is not found, store the current number and its index for the future use. We will do that, right? So yeah, now our loop will end. We will done the close bracket. So here the time complexity will be, TC will be big O of n, because we are using a hash map. We are running only one for loop, right?